Hi there, Turgeon here, bringing you physics from afar. Sorry that I can't get my camera to work right now. Remember, if I go fast, just pause, rewind. This is about the egg drop data. Here we go. Remember, you're going to fill in these different descriptions, and I'm looking for specific descriptions. Think about the actual physical drop, and that applies to everything here. Think about the physical drop. So how do I fill this data table in? Let's go start to finish. First of all, to get this text so that it will wrap around instead of looking like this, you want to highlight. You can highlight the entire row like this and just choose text wrap. You can see where I'm clicking here, I hope. And then that will wrap the text around as you described. Now, this is the mass. So all I did to fill that in, that is the mass of the egg as we discussed. Type it in 0.055. That is the mass of everybody's egg. Now look, I can click and drag the dot on the bottom right, click and drag the dot on the bottom right, and it will copy all of those. Try again, it'll work. Potential energy, that is equal to mgh. You'll remember that. This is potential energy is mgh. So I'm just going to type in mgh. How? Type the equal sign. I'm going to physically click on the mass here. Then I'm going to multiply, which is shift 8, the asterisk. I'm going to do 9.8. And then I'm going to multiply by the height, h, by clicking, physically click here. Now I'm going to hit enter. It's suggesting everything. I'll accept that. But if you didn't accept that, you could just click here, drag the bottom right dot. Kinetic energy, this is equal to the potential energy. Why is that equal to the potential energy? Because the kinetic energy, you can see what I just did there, I just did a formula equal to that. Because the kinetic energy is happening at the end. The kinetic energy is at the end. The potential energy is at the beginning before it was dropped. The velocity. Keep in mind that the whole purpose of the kinetic and potential energy was just to get the velocity. This is not an energy project, this is a momentum project. Write that in your notes over here. Let me explain how we're going to get the velocity. So, the kinetic energy is 1/2 mv squared. Again, if this is too fast, just pause. Multiply both sides by 2 to cancel out this 1/2. Now I have 2 ke equals mv squared. Divide both sides by m to cancel out the m. So now I have 2 ke over m equals v squared. Take the square root of both sides. V is equal to the square root of 2 ke over m. Here's how I input that formula. You can use the SQRT. So I'm going to just type equals, and I'm going to type SQRT, and the square root of 2 multiplied by the kinetic energy, click that, divided by the mass, click that, close parentheses, hit enter, boom, there's all of my velocities. And remember, if you didn't have all the velocities, you could just grab and drag the lower right dot and it will do it for everything. The force is the force exerted by, this is the force exerted by the device, the project, the thing you built, by the device onto your egg, which we're assuming is probably around 25 newtons if it broke. So now we're going to calculate the force, the tension, the time, sorry, I'm trying to rush here. Trying to calculate the time. So the time is equal to, if you look at the equation for momentum, Ft equals m delta v, you'll see that the time is equal to mass multiplied by velocity divided by the force. I just solved ft equals m delta v, and I got a bunch of times. So now, when it comes to the paper questions, and you're gonna put things in your own words, but we're gonna be looking at what's happening with these times. So there's your data table, how to enter all the formulas. This has been Turgeon, bringing you physics from afar.